Good day, viewers. Welcome to my YouTube channel, Master David and Victor Adewale Adeleke. Okay, without wasting much time, let's quickly dive into the deal of the day. Today, I'll be deriving the cosine rule for us. I'll be deriving the cosine rule. This is one class in our playlist. This is a playlist. Check on the playlist. If you are just stumbling on this video, check on the playlist. Tagged geometry with Adevic. Very, very beautiful formulas are being proved in that playlist. Watch them. Try to make yourself abreast with the information for geometry before you go for any external exams or you sit for any exams at all. Okay, now let's see what we can do. This is cosine rule. Now the cosine rule actually is a kind of formula that is used specifically in geometry. It's used in bearings. Yes, we use them in bearing. We use cosine rule in bearing. We also use it in several places, even in equilibrium forces in physics. We used it. Cosine rule, very important. Just that there was a little touch or a little application of physics to the law when it comes to physics. So the same thing applies when you talk about the parallelogram law of vector. You find the cosine rule there, but it was used in another fashion. So just your understanding that matters a lot. Once you understand what is going on, you will not have a problem with that. Okay, before we dive into that, I want to first of all drop some informations on ground. Let's keep to our hearts that cos 180 minus theta is always equals to the negative cos theta. Keep this one to heart. Cos 180 minus theta is equals to minus cos theta, which means that if you have 180, let's say theta is 20, so 180 minus 20, that will be 160. So cos 160 will be the same as negative what? Cos 20. Yes, because theta is what is 20. So that is that. That is one rule you must keep to heart. Then we also know, remember the Pythagoras law that say a square plus what plus b square equals what 6 squared. These are very important laws that we need to keep to heart before we can delve into the derivation of what of the cosine rule. So a squared plus b squared must be equals to what? Must be equals to c squared. This is one you must keep to heart also. Now, if you've noted that, now let's move on to the next. So now, very, very simple. What are we going to do? Let's try to label all of these. Now let's call this height, this length here, that's the length BT. You see, you can see this is T labeled T, this is B. Let's call it H. Yes, then let's call this length here. Now this is ABC. This is a triangle ABC. Yes, and this triangle, you can see that all of the angles are what? They are all acute. All the angles are acute. They are not up to 90 degrees. So they are all what? Acute angles. So this is derivation. I'm going to derive the same formulas but different methods. Yes, the same formula but different method. This is the first approach when you are using an acute triangle. That's an angle a triangle that is having acute angles. Then this one for a triangle that is having one what acute angle. I just want to tell you that all triangles, this method of what this cosine rule method that I want to derive applies to all what triangles. Just know what you are doing. So let's show how it applies to these two triangles here. So I'm going to see if I'm going to minimize this little space here for that what for the first solution. The first solution to the what derivation of cosine rule. Now we've made here H. Now since here is ABC, since here is ABC, so this is going to be angle A, this is going to be angle B, and this is going to be what? Angle C. So this is going to be what? The length A. This is going to be the what? The length small letter C, and this is going to be the what? The length B. Yes. Now can we make here X? If you are making here X, now automatically what will this place? Since the whole length here is B, then this point here is going to be what? B minus X. Yes, B minus X. So automatically, yeah, from here you can use your trigonometrical information. The first law I gave you, Pythagoras, from what? From triangle B, let's say BTC. Yes, from triangle BTC. Where's BTC? This is triangle B, T, and C. So from triangle BTC, you can see that B minus X, because remember the law of Pythagoras, A square plus B square equals to C square. What is the A? The A could be the what? The opposite, while the B is the what? The adjacent, and the C is always the what? The hypotenuse. So this is the hypotenuse because we are taking this C as an angle here. Yes, we are taking this C as an angle. So from the Pythagoras principle, you know that that it will be what? B minus X all squared, then plus H squared must be equals to what? Must be equals to A squared. Yeah, I'm trying to be as neat as possible. So you can see that now. So B minus X all squared plus H squared must be equals to what? A squared. Let's try to expand. If you are expanding that, you are going to get b squared minus 2bx plus x squared. Then that is, we've expanded this guy now. Yeah, we've expanded it to become like this. Then plus your what? Plus your h square equals what? Equals your a square. That is it. Now, once you've noted this, let's keep this one to heart first. Now, remember also from, or let's note also from triangle what? From triangle BTA, note from triangle BTA, that is this triangle BT, this is T, then A. Note that what? That h squared plus x squared will also be equal to c squared because we are using this angle here. So we have what? H squared plus what? Plus x squared must be equal to what? C squared. So making h subject formula here, h squared will be equal to what? C squared minus what? Yes, so from that first, we know it was Pythagoras we're following. So h squared will be equals to what? If you rearrange this equation algebraically, you get h squared will be equals to c squared minus what? X squared. Once you've had that, now the next thing to do is to substitute the value of h, which you have gotten from here, into this equation. This first one you have had here. So I think we can call this equation 2, then this one equation 1. Yeah, I'm trying to minimize space. So what we are saying is substitute 2 from what? Substitute h from 2 into what? Into 1. So what we are saying is that substitute h from 2 into what? Into 1. Now when you do that, you get what? B squared minus what? 2bx plus x squared plus, what is h now? H is what? H is c squared minus what? X squared equals to what? A squared. Yeah, so since you've had that, what is going to happen now? X squared is going to eliminate x squared. So we have x squared eliminating x squared. And we have finally that a squared is equals to what? Is equals to b plus c. You can just say b squared plus c squared. I'm trying to rearrange properly. We have 2bx. Now, what is x? From triangle BTA, and the cos of A would be equals to what? Would be equals to adjacent over hypotenuse. If you don't understand that, go and check my video. I explained the principle of what? Of SOHCAHTOA there, and I also talked about how to note the hypotenuse, the adjacent, and the opposite in every right angle triangle. So this is a right angle triangle. BTA is a right angle triangle. Triangle BTA is a right angle triangle. So from, if you check that now, cos is always equals to what? It's always equals to adjacent over hypotenuse. That adjacent is x over what? Over the hypotenuse, which is c. So we have x over what? Over c. So if you are making x right formula from here, x finally will be equals to what? X will be equals to c cos a. Yes, x will be equals to c cos a. So we have gotten the value for what? For x. So once you have gotten this value for x now, you can go back to this equation now. Therefore, a square will be equals to b square plus what? Plus c square minus 2b. What is x? X is c cos a. Now this is the formula. This is the final proof. Now this is the what? The final proof. Yes. This is the formula that many of us are very familiar with, that we use in solving different questions, especially our bearing questions. Yes, this formula applies very well to find the length and also to find angle. You can use it to find angle. Just make sure the formula of A. Make sure the formula of A here. This big letter A, which is the angle, and you get a formula to get what? Just A. Yes, this is a formula that applies. Now let's see how we're going to also use this method, or this obtuse. This one that has an obtuse angle. You can see this is an obtuse angle because it's what is greater than 90 degree. Yeah, so it's an obtuse. Now it's greater than 90 degree, but not up to 180. So it's within the range of 180, 179 to 0. Yes, or 180 to 0. So that is it. So what do we do here? Okay, now let's call this x. Let's call this point here t. Now we've given here a, we've given here b. So automatically this length here is going to be small a, and this length that is opposite to the what? Okay, let me just explain the system of operation here. Whenever you have a triangle A, B, C, yes, the angle, the length or the line that is opposite to what? The angle, or the angle. is what? It's always the small length. It's always the smaller length. So this place is going to be small b. This place is going to be what? This place is going to be small a, and this place is going to be small c. So that's just the system of operation. So let's continue. You can see that now. So let's quickly move on. What are we going to do here now? Since we've add a here and we've add, I think we now understand how I labeled all this. So we can call here c, yes, and we can call this length here. We can call it what? B. Yeah, we can call this one B. Yes. So once you have noted this, now the next thing to do is we have triangle what? Triangle CBT. Yes. So from triangle CBT, we know that what you can see is because here is C and here is X. The length from this point from B to A is C, and length from A to T is X. So automatically the length from B to T, the distance from here to here is going to be what? The summation of these two lengths. So we have C plus X. So we are talking about the whole triangle now, triangle CBT. Yes, the right angle triangle CBT. So you can see H is going to be H squared plus what? C plus, okay, let's try to be neat. C plus X squared is going to be equal to the hypotenuse, which is what? A squared. So we still made it equals to A squared, but we want to see, try to see if we can get the same thing we got here. So from here, what do we do? We expand. So we are going to have H squared plus what? Plus C squared plus C squared plus what? 2CX then plus X squared equals to what? A squared. So from here, what do we do? Now recall of note that from triangle what? From triangle ACT, from triangle ACT, this triangle here, a right angle triangle here, which was added. This is the triangle we're actually looking for. We're trying to solve. You get? So we just added this to make it what? To make it merged. To merge it with what? To merge it with this. To make it look like a right angle triangle, so that we can solve for the value of what? For A. So that is the length. This A here. That's what we're looking for. So from triangle ACT, yes, it's going to become what? We're going to have H squared plus X squared equals B square. Yes, H square plus X square equals B square. That's Pythagoras theorem. So we're using Pythagoras here. So from here, what do we do now? We can make sure formula of H square. H square will become B square minus what? Minus X square. So we're going to substitute this value of H now into this. And when you do that, yes, you're having this. Let me draw lines. Yes. So you're going to be writing, instead of writing H square now, we are going to write what? This is now H square. So we're going to be writing H square in terms of this. So we're going to have B square minus X square plus C square. Then what else? Then plus 2CX then plus X square equals A square. So what happens here? You can see again that X squared what? Eliminates. Then we have what? We have finally that what? That A square equals to B square plus what? You can see plus C square. Then what do we have? Plus 2CX. Now, but in this case, now what is X from this place? What is going to be X? Now, if this is angle A, this was angle A, let's do a little algebra, a little geometry, sorry. If this was angle A and this is angle, let's say P, angle P. Now, we already know, we are very familiar from our geometry that the angle, the sum of the angles in the straight line must give you what? 180. So let me quickly do a little arithmetic down here. So which means that angle A plus angle P must be equal to what? 180 degree. So if I'm making angle P, so just formula, angle P will be what? Angle 180 minus what? Minus angle A. So this P here can be written as 180 minus what? Angle A. So this angle here, if I'm writing P, so let's just keep it in our mind, where angle P is equals 180 minus angle A. So yes, we know that now. So since we've noted this, let's quickly see what we can do from ends. Okay, so now since we've noted that P is equals to what? 180. We have gotten that. I've explained how we got that P is equals to this. So automatically, which means that we can do a little trigonometry now by saying that since here is 180 minus A, we can say cos of this P, of the angle P, of which you already know that the angle P is what? Is 180, sorry, minus the angle A equals must be equal to what now? Cos of an angle is what? Adjacent over hypotenuse. That is what? X over what? Cos of every triangle, of every right angle triangle is what? Adjacent over hypotenuse. I corrected that. So it's that's what we are going to get x, which is the adjacent over the hypotenuse. So we have x over b. So we are going to get x over what? Over b. But remember also that I explained that the cos, whenever you have the cos from the beginning of the video, I said cos 180 minus theta is must be equal to the negative cos theta. Is that true? Yes. So automatically, which means we can rewrite this cos 180 minus a to be what? We can clean everything here and rewrite minus cos a. Yes, we can rewrite what? Minus cos a to be this. Yes. So once you've noted that, let's see what we can do from here. So from here, you can see now we can make Surject's formula of what? Of what? Of x. And if you're making Surject's formula of x, we are going to cross multiply this over 1. So x will be equals to what? The minus bc cos a minus b, sorry. You can see because b multiplied what? This minus cos a. So we have minus b cos a. So x is finally what? Minus b cos a. So plugging the value for x into this place now, we get what? The equation. So let's see what that will be. So from here now, what do we do now? You can see this was x. So therefore, don't forget a square equals b square plus c square plus 2c, what is x, minus b cos what? A. So when this multiplies, we are going to come out with what? A square equals b square plus c square minus, because 2c is going to go into the bracket, so we have minus 2c times b, we have 2bc, then cos what? Cos a. This is just the proof of the word of the cosine rule. This is how simple and interesting it is, using the word, using the acute triangle and the what? And the obtuse triangle, or yes, the obtuse triangle, to still prove what? The same thing. So every triangle, for every triangle that has any angle, that has any shape that has three sides, this cosine rule applies. Now you can also, this is the same thing, you can use the same thing, this same formula applies to the others. Okay, I think let me quickly show that quickly. There are other formulas for b and for c. I may not want to prove that, but with this information that you have already done, you will be able to what? To prove what I've already explained. So the same, with using the same process of or the method of operation, you can prove the formulas for b and for what? And for c. You can find the length for what? For b and for c. And also you can also mix up this formula of c and b, the big letter, which is their angles, big letter of b and the big letter of what? Of c. You can make sure the formula of these ones. You should know how to do that, or else I may create another video for that. If you want videos on that, drop on the comment section. I'll create a video on that, making sure the formula of what? Of this b and the c and the a, to make what? To understand how to find their respective angles, the respective angles for a, b, c, like that. So that is just how simple they are. If you are yet to subscribe to my YouTube channel, do it to subscribe, like and share this video. Stay tuned.